Hello everyone, welcome to week 5 for Algebra 1b, going over polynomial operations. For week 5, make sure you're going through our textbook, make sure you're taking notes, make sure you're doing all those things that good students do, accessing all your resources to learn math, show me what you're learning, and letting me know if you need help. Come to my online classroom, text me, call me, let me know if you need help going over any of the problems. Here's what we're going to be learning in week 5. If I give you an algebraic expression, I want you to define if it's a polynomial and use all the appropriate vocabulary to describe the polynomial. If I give you two polynomials, can you add or subtract them by combining like terms and using the distributive property? If I give you two polynomials, can you multiply them together using the distributive property and other exponent properties? And finally, when multiplying two binomials together, we're going to look at special patterns such as squaring a binomial and the sum and difference patterns. So it's all about polynomials this week. So what is a polynomial? Well, I'm glad you asked. A polynomial, when we use that term in math, you should write this down in your notes. It is a term or the sum, that's addition, of terms, where each term includes factors involve multiplication, factors of numbers and variables. Polynomials always have whole number exponents for the numbers and variables. So here's a bunch of vocabulary. Remember we talked about vocabulary? And here's an example of a polynomial. So let's first start off with what is a coefficient? A coefficient is the number in front of or at the very beginning of a term. So here we have four terms, 1, 2, 3, 4. Again, that's what a term is. It's numbers and variables multiplied together. So we have four terms. The coefficient is the number in front of the term. So in this first term right here, the coefficient would be 3. In the second term, the coefficient would be a negative 5. The third term would have a coefficient of 11, and the fourth term a coefficient of 7. Fourth term actually would be considered our constant term, is the plus 7 at the end. Let's change colors. So hopefully that helps you understand a little bit about what a coefficient is. The leading coefficient is we find the term with the largest power. In this case, it's x to the third power. And the leading coefficient is the coefficient in front. So the leading coefficient would be positive 3. A term, obviously we have four terms in this example. But we're going to look at things with 3 terms, 4 terms, 2 terms, sometimes even 1 term. The degree of a polynomial, that is the largest exponent in a term. So the degree of this polynomial, I have an x to the third power right here. So this is a third degree polynomial. I know if I say it's a third degree polynomial, it means somewhere I have a variable to the third power, and that defines how the graph of this polynomial works and how the equation actually works as well too. Finally, we have what's called standard form. Standard form means you start with the largest term, the largest degree term, and there's no parentheses. So this is a standard because we're starting with the x to the third power term. Then we have the next x to the second power term. And then we have the 11 to the x to the first power term. And finally, we have our constant term at the very end. So a lot of this vocabulary, coefficient, terms, constants, degree, standard form. I'm going to be using those a lot in this video and as you're working with problems throughout this week. So I really want you to have a good starting understanding of what these are. You can find these in your textbook as well and keep referring to them and just get comfortable with these words. All right, so we've got our polynomials. We've got a set of new vocabulary. Let's take this polynomial and let's understand what's going on here. First of all, how many terms does this polynomial have? Well, I'm going to count three things being added or subtracted. 1, 2, 3. So this is 3 terms. I want to write it in standard form, which needs to mean I put the largest power first. So when I look at this term here, it's got a to the 3rd power. This term has a to the 5th power, and this term has a to the 1st power. I'm going to write a 1 there. So in standard form, I need to write the largest power term first. That's going to be the 6a to the 5th. And because it's positive, this is a plus 6, I know that's a positive value for 6. So 6a to the 5th power goes in the very beginning. Now I put the next largest term. That's going to be the a to the 3rd. And there's a negative 5, so I have to put the negative along with it. So it's going to be minus 5a to the 3rd. And at the very end, I put my least power. That's a to the 1st, so it's minus 15a. My leading coefficient, in this case, is 6. The degree of this polynomial is 5, because this is the a to the 5th power. So there we go. That's just some working with polynomials, and it's now in standard form. Sometimes we call this descending order too, where you descend from the largest power in the beginning to the smallest power at the very end. All right. Now we have a polynomials. We can do some things together, right? We learn about numbers, and then we learn how to add, subtract, multiply, and divide. And then we learn about decimals, and we add, subtract, multiply, divide. And we learn about fractions, we add, subtract, multiply, and divide. Now that we're getting into algebra and algebraic expressions, we're not just going to have numbers, but we'll have numbers and variables together in an expression. And we needed to know how to add, subtract, multiply, and divide those as well. Again, a lot of what we're going to be doing this week with polynomials and next week with factoring is we're starting to learn some skills, some mathematical tools, so that we can start doing more complex math. Everything you're going to do in algebra, geometry, algebra 2, pre-calculus, calculus, if you get on that in college level math, you're going to need a good foundation of working with polynomials and some complicated expressions. So here we go. Let's talk about how do we add polynomials then. So adding, you already kind of know how to do this. To add, we remove the parentheses and we combine like terms. So here we got 5a squared plus 2a minus 5. And I'm adding to this polynomial 6a squared plus 3. Well, if it's adding, that means I'm going to take 5a squared plus 2a minus 5. I'm going to add to that plus 6a squared. And I'm also going to add to that 3. Now I kind of have one big polynomial, but I want to combine like terms. Like terms have the same variable with the same exponent. So when I look at combining, let me switch colors to red. I'm going to start with my largest power. So I've got a 5a squared here. I'm going to look for anything else with a squared. I've got a 6a squared. This 5 is positive, and this is a plus 6. So 5a squared plus 6a squared is going to give me 11a squared at the very beginning. I want to write it in standard form in descending order. So I'm going to start with my largest power. Next, I go find my next to largest power of a is a squared, so I need to look for a to the 1st power. Now I only have one term there. So I've got plus 2a, so I'm going to write my plus 2a, and that's the next term. Finally, I have my constant term at the end. There's no more powers of a to the 0 is just kind of nothing, so or it's 1, so we just look at my constants. I have negative 5 plus 3. Negative 5 plus 3 ends up equaling negative 2. So there we go. We just added those two polynomials together. We added this trinomial, because there's 3 terms, 1, 2, 3. And we added to that a binomial. So trinomial with 3 terms, and a binomial has 2 terms. And we ended up with this trinomial down here. A second degree trinomial with a leading coefficient of 11. and a constant term of -2. So just subtract polynomials. How do we go about subtracting then? Well, we kind of already know how to do this, but this is where it gets a little bit trickier, is when we have subtraction, I'm subtracting the 6a squared and I'm subtracting the 3. And when we think of subtraction, we can also think of adding the opposite, right? Adding the opposite. That negative sign is kind of like the opposite. So we distribute the negative. I still have 5a squared plus 2a minus 5, but I'm subtracting this. I'm subtracting 6a squared. And I'm subtracting 3, so minus 3. Notice how this was a positive 6a squared, and now it's a minus 6a squared. This was a plus 3, now it's a minus 3. It's because, again, it's adding the opposite. So now I can combine all these together and then do what I did before with the addition method. One thing that might help, can't change color on this one now. One thing that may help, and I suggest students to do, is if you're going to make a mistake, it's going to be with your negative sign or your subtraction. You can turn everything into addition. So I could rewrite this all as 5a squared plus 2a plus -5 plus -6a squared plus -3. And now when I move things around, it's a little easier to keep track of what's positive and what's negative. All right, so now let's do, I still can't change my colors. It's frustrating. Well, let's combine my a squared. So I got 5a squared. I can combine that with this -6a squared. There's no other a squareds. But notice in the previous example with adding, it was 5 plus 6a. This is now 5 minus 6a, so it's going to give me -a squared. Now let's look at the a's. I got plus 2a right there. And finally, we've got -5 minus 3, or plus -3. Together, that gives me -8. And there we go. We've just now subtracted those two polynomials. Again, make sure you're dealing with the subtraction by distributing it in the negative into the whole second polynomial that you're subtracting with. Okay, multiplying. This is actually kind of fun. I like multiplying polynomials. To multiply polynomials, we need to use the distributive property again. Now, this one's pretty easy, but we've got 4a to the third, and I'm multiplying by 7a minus 9. Now, the distributive property says, well, if I multiply that term, then I also have to multiply that term. Both those terms get 4a to the third. So it looks kind of something like this now. I have 4 times a to the third power times the 7a minus, and we also distribute it to the other one. We have 4a to the third times 9. See there how it got distributed to both of these terms until two terms? Both those terms get multiplied by 4a to the third. Now it's just a matter of multiplying and using all my exponent properties correctly. So 4 times 7 is going to be 28. A to the third times 1 more a is going to give me a to the fourth. So I got 4 a's all together. Minus 4 times 9 is going to be 36. I still have a to the third. There we go. We just successfully multiplied this binomial here by what's called a monomial. There's only one term that was multiplied by both of those two terms. That's a distributive property. That's how we evolve. That's how we get started with multiplying polynomials. Well, what do I do now if I have a binomial multiplied by a binomial? So I had two terms times two terms. We still use the distributive property, but we have to go one at a time through each term. So we start with this 5y, that's the first term there, and that gets distributed to the 2y. So 5y times 2y is going to give me 10y squared. And then the 5y gets distributed to the other one. It gets distributed to 9. So 5y times 9 is going to give me 45y. And it's positive because both the 5 is positive and the 9 is positive. All right, well, that's good, but I got a whole nother term to work with. I still have my 3 right here. In fact, it's negative, so I'm going to change this to plus negative, but this is a negative 3 multiplying everything. So this negative 3 multiplies the 2y. Negative 3 times 2 is going to be minus 6, or negative 6 with the y. And then the negative 3 multiplies the 9 to give me negative 27. So do you see how we have two terms, and each term gets the distributive property with what's in the other polynomial? So we have the 5y multiplied both terms, and then the negative 3 multiplied by both terms. So we ended up with 4 terms altogether, and I'm going to see if there's any terms that I can combine, any like terms. So I got 10y squared, but there's no other y squareds. But I do have two terms that have one power of y. So 45y minus 6y, I can combine those. They both have y to the first power. So 45 minus 6 gives me 39. So that's plus 39y. And my constant at the very end is negative or minus 27. Hey, there we are. We multiplied those two binomials together. We ended up with a trinomial, a second degree trinomial. So we use, if you're multiplying, again, it's the distributive property, making sure everything gets multiplied by each term. Let's do one more. What if I have a 4 and I'm multiplying my 4 times this x plus 5, and I'm multiplying that by this 2x squared plus x minus 8. So I've got three things multiplied here. A constant 4, a binomial x plus 5, and a trinomial. Well, let's just go through and we'll use the distributive property. So this 4 is going to get multiplied by both of those. To get 4 times x, that's 4x, and plus 5, 4 times 5 is 20. Well, I don't like that green row. I got to remember not to use it. Now I still have, so I'm going to rewrite it with this blue here. So I've got 4x plus 20, and I get that from distributing this 4 right here. 4 times x plus 4 times 5. I still got this whole stuff here, so we still got 2x squared plus x minus 8, and I've got some heavy-duty distributing to do here. So let's start with the 4x. The 4x is multiplied by the 2x squared. 4 times 2 is 8. X to the first times x squared is going to be 3 x's. So it's going to be x to the third. Now I've got 4x times that x right there is going to give me 4x squared. And then the 4x multiplies the negative 8 at the end to give me minus 32x. All right, now that's great. Well, let's move on. We've got another one to go here. We've got the 20. The 20 multiplies the 2x to give me plus 40x. Whoops, 2x squared plus, so it gives me 40x squared. 20 times 2 is 40, plus I got the x squared. 20 times x is going to be plus 20x. And 20 times the negative 8 is minus 160. So you can see here we had a binomial of two terms times a trinomial with 3 terms, and guess how many things we multiplied? We had 1, 2, 3, 4, 5, 6 different multiplication problems we needed to do. So you can always know how many you need to do based on what you're doing. 2 terms polynomial multiplied by a 3-term polynomial should mean you have 6 different things you have to multiply. All right, now at the end though, I gotta make sure, are there any like terms, things that I can combine? I want to simplify this down. So let's start with the largest power. I've got 8x to the third, and I don't see any other x to the thirds, so I'm going to write that first. It's my leading coefficient of 8, and there's my leading term. And I'm going to have a polynomial with degree of 3. All right, now let's look at my next value. I got 4x squared, and I've got a 40x squared. Those are my x squared terms. Those are both addition, so I'm going to add those together to make 44x squared. Now I've got my x to the first power terms. I've got a minus 32x and a plus 20. that's negative 32 plus 20. Those are going to combine to be more negative. It's going to combine to be negative 12x. And finally, I got my constant term at the very end of negative 160. So our final result is a polynomial with 4 terms with a degree of 3 and a leading coefficient of 8. There we go. We multiplied all that together using the distributive property. Okay, a couple special cases as we're digging into multiplying. Multiplying we can represent with exponents, right? Exponents is just repeated multiplication. So what do I do when I see something like this? Here's our binomial 3a plus 5 and I want to square it. How do we simplify? How do we actually square 3a plus 5? Well, squaring means there's 2 of them, right? So the first thing I want to do is rewrite this as 3a plus 5. There's one of them, but it's 2 3a plus 5s multiplied together. And now this looks a lot more like the problems we were just working on, right? So I'm going to do 3a times 3a. 3 times 3 is 9. A times a is a squared. Then I got 3a times 5 to get plus 15a. Another 5 times 3a to get another 15a. And then finally a 5 times 5 to get 25. These two middle terms are like terms, so I can rewrite it as 9a squared plus 30a plus 25. So when you see a binomial squared, just immediately rewrite it as the same binomial times the same binomial. And then do your multiplication steps. You'll also see what's this case right here. Let's see what happens when we multiply this. We have x minus 4 times x plus 4. Let's use our distributive properties. We get x times x gives me x squared. X times the 4 gives me plus 4x. And now we move on to the next term. Negative 4 times x gives me negative 4x. And negative 4 times the 4 gives me negative 16. Well, when I go to simplify it, what happens to plus 4x and minus 4x? They go to 0. So this is a special case because things simplify down really nicely. If you're multiplying the same binomial, and one's just positive and one's negative, but it's the same numbers, x, 4, 4, then the middle terms will always turn it into 0, and you're just left with x squared minus 16. Let's do another one. There's a similar one over here. So I've got 2a is going to multiply this 2a. 2 times 2 is 4. A times a is a squared. Then I take the 2a times the negative 7. So 2a minus 7 is going to be minus 14a. But then I have a positive 7 times 2a. So that's a plus 14a. Again, there you go. Your middle terms are going to cancel. And we have 7 times a 7 is minus 49. So when I combine my middle terms, when I simplify this polynomial down, we end up with 4a squared minus 49. And there's our binomial, 2 terms, both are a degree of 2, and it's our sum and difference pattern when we're multiplying binomials together. Okay, in the live class, we're going to play a game of Kahoot, but I don't know if we'll have a live class. So if you attend the live class, you get to play this. If not, you just get to jump right past this and summarize what we did. So we talked a lot about polynomials this week. What is a polynomial? All the vocabulary to describe polynomials, and then we learned how to add and subtract them. We learned how to multiply them using all this correct terminology. Hopefully you followed along with the distributive property and how we were able to multiply bit by bit, and then simplify at the very end by combining like terms. And then we did a little bit of special patterns of multiplying in terms of squaring a binomial, or when we have the sum and difference pattern. Hopefully this was helpful for you as you're working on algebra stuff for this week. Let me know if you have any questions.